An exponential graph, this is all grade 12 review for the beginning part, is a function in the form f of x equals some base that's greater than 0 to the power x. So it has to be to the power of variable, right? Okay, so this would be the case where we have exponential growth. That's where a is greater than 1. So here's a question for you. What's the limit as x goes to infinity of that exponential function? Does everybody see it's infinity? It grows exponentially, right? And what about when it goes to negative infinity? No, it's not negative infinity. 0. Do you see it's pretty much leveling? That's why we have an asymptote over there, right? Because it's leveling at 0. Okay, when we have exponential decay, that's where we have basically a fraction usually. So what is the limit as x goes to infinity? Yes, it's basically switched, right? This would be infinity. Yes? Okay, so let's find, so now we have limits of exponential functions on top of this here. So find the limit as x goes to negative infinity of 2 to the power x minus 1. So I'll give you a second to figure that out. Huh? This is negative infinity, this is positive infinity. Yeah, like look at the graph. The height is positive infinity, right? Okay, so if I plug this in, I get 2 to the power negative infinity minus 1. What would a base, and the x is going basically towards the left, right? It's 0, do you see? So this is really 0 minus 1, so this would be negative 1. Yep. All right. What about the next one? I'll give you a second. Well, so if you plug it in directly, you're getting infinity over infinity plus 1. There's another technique when we had x going to infinity, however. Or you can factor, yes. What could you factor out here?
We need to factor out the x.
Not just the e. E to the power 2x. And what are we left with when I factor that out? 1 plus 1 over e to the power 2x, yes? These would cancel, right? And so if I plug in infinity now, yeah, you get 0 there. And so then, so this would go to 0, yes? And so what do you get then? You get 1. Why is it 0? Because if you think about this for a second, e to the power infinity is infinity, yes? But this is 1 over a big number, which is essentially 0. 1 over a big number is a really, really small number. 0. It's roughly 0. But this is limits. It's all rough, right? Okay. Okay, definition of e. The most useful base for exponential logarithmic functions is the number denoted by the letter e. Like pi, this is an irrational number whose value is constant. This is kind of cool. So I know I kind of showed you where e came from when we did pre-calc, but now we can actually examine this as a limit. E is the limit when n goes to infinity of 1 plus 1 over n to the power n. And so I know when I did this in pre-calc, we just kept on putting in bigger and bigger and bigger and bigger numbers, and you could see it leveling off at the 2.718, blah, blah, blah. But this is actually the definition in calculus. When n gets exponentially, or just really big, then that number approaches 2.71, that constant. Okay, so here's your first derivative using ease. The exponential function derivative, if y equals e to the power x, then y prime is e to the power x. So I know when I taught the U of W course, we always do the definition of this, and I could, but essentially this is one of those that the derivative is itself. Now when we use the chain rule, it actually, you have the extra u that you have to have. So let's just go back here. For any point on the curve y equals e to the power x, the slope of the tangent line is the same as the y value of the function. In other words, the derivative of this particular function is itself. So maybe I'll explain that a little bit more. Remember, e to the power x looks like this, right? So what they're saying here is any time that we see like the slope right here is a slope of, of 1. The slope of here is essentially whatever the x value is e to the power x is itself. So you see when x is 0, this is e to the power 0. That's how I'm getting the 1. But do you see it would be a slope of 1 if you kind of looked at it estimation. They're saying any part on here, like for instance, if this was say 2, this slope would be e to the power 2. So anywhere upon this curve, it's actually the slope is itself. Okay, so let's find the following derivatives using the chain rule. So y is e to the power x squared plus x, so y prime would be itself, which is e to the power x squared plus x, but then you have to times it by the chain, which is 2x plus 1. There you go. Because it's in the form, like essentially, if you didn't understand that, you could say let u equal x squared plus x, then du would be 2x plus 1, yes? So then y equals e to the power u, right? Then the derivative is e to the power u times u prime, which is that part of it, right? So okay, let's do the next one. The next one's a little bit crazy, maybe. The next one has e to the power. So we have a chain rule with the e. And then here we have a product rule with a chain rule. So it gets a little intense. So I'm going to give you a second to try it. Okay, y prime is going to be e to the power itself. Is that a 3, by the way? And then you got to times that by the derivative of that exponent, so or the power. So that would be 6x squared plus 1/2 x to the negative 1. And then that goes away. So then it's 2x times e to the power sine x plus x squared. And then the derivative of e to the power sine x would be e to the power sine x times the derivative of that power, which would be cos x. So I would clean this up a little bit, however, with this. Yeah, like, because have you done your homework? A lot of those answers are never.
But you said this is going to make us mess up. This is just.
And then maybe, I'm just saying some of the things that they would do is they'd probably put that in front, and they might change that. Yeah. Yeah. Perfect. Okay. So if the base is not e, then you have to use a different derivative. And the derivative is, you have to essentially multiply it by an additional ln a. So if you're using the chain rule, not only are you doing itself times the power, you have to do an additional ln a. And of course, when it's ln e, what happens? It's 1. So essentially, we were doing the ln e for the other one, but ln e is just 1. Yeah. So what's the derivative of 5 to the power x? It would be 5 to the power x times, well, x is just 1, but then ln 5. Well, you could say times 1, not times 5. Okay? Again, you probably put this in front as your answer. So ln 5 times 5 to the power x. Anyways, maybe, yeah. Okay, the next one is definitely a chain. So what would we get there? Well, because sine x is not just the usual x, right? So the derivative of 3 to the power something is 3 to the power something, right? And then ln 3. And then you have to do the derivative of sine x, which is cos x. And again, you can have this in any order, right? Or you could have ln 3 cos x times 3 to the power sine x. So if a is greater than 1 and a is not, greater than 0 and not equal to 1, the exponential function f of x equals a to the power x is either increasing or decreasing. It's decreasing when it's fractions, right? And it's increasing when it's bigger than 1. And so it is a one-to-one function. Because it would pass the horizontal line test, right? If it's increasing or it's decreasing, it's not coming back up, right? So it would pass the horizontal line test. So that means its inverse is called the, what? You should know this from grade 12. The logarithmic function, right? With a base a. So a to the power, do you remember how to do this? If a to the power y equals x, then y equals, no. Log base a of x, yes. Remember this?
Yeah.
Okay, so let's do a quick review of pre-cal. If you have a logarithm of two things multiplied as your argument, you can separate them as?
Log x plus log y.
Very good. Log of x plus log of y. What happens if it's division? It becomes a minus, so log of x subtract log of y. And what about the power rule? Put the r in front. See, you guys all know this without looking at a thing, right? What about the change of base? Ooh. What's log of x base a equal to? Like log of something over log of something. Log of x, yeah, divided by log of a. You didn't use that one too much, but. So the nice thing about your calculators, I think most of your calculators you can change the base and put it directly in. It's only, does everybody remember who had that kind of calculator? Remember we kind of discussed it last year. Okay, so let's move on. So here's a graph of a logarithmic function. Do you remember this? So what is the limit as n goes to infinity of log of x? Infinity, yes, thank you. It's increasing, right? It doesn't look like it's increasing that fast, but it's increasing. Yeah. And so
Shouldn't that be x approaching?
it should be actually. It should be an x. Yeah. Sorry about that. That should be an x. Anyways, what about this one? Yes, negative infinity. Very good. Well, look at when you're coming from the right closer and closer to 0, it's taking you to negative infinity height, right? Yeah, remember limits are the y values. Yep. So example, find the limit as x goes to 0 of ln of cos of 0. Well, there's nothing you can do except sub her in, so I get ln of cos of 0. What's cos of 0 equal to? What's cos of 0 equal to? Huh? 1. So this would be ln of 1. So what's ln of 1 equal to? here's my trig. Here's 0. That coordinate right there, sorry, is 1, 0. So cos value when the angle is 0 is 1. What's ln of 1?
0.
Yeah, it's 0.
Are we supposed to remember this?
Well, because the base is e. E to the power what gives me 1, right? Yeah. Okay, so yeah, you have to know that. Okay, how about this one? The limit as x goes to 4 on the right side of ln x squared minus 16. You do. I don't know if you need to know difference of squares at all.
Make it easier.
I'm sorry?
It might make it easier, but then again.
No. So no. So
I said
this would be the ln of 0. The reason why it's a plus though is if this is essentially ln of 0 going from the right hand side, right? So the way you should be looking at this is 4 plus means something a little bit bigger than 4. So if I square this and then subtract 16, I'm going to get something a little bit bigger than 0. So that's where I'm saying the 0 plus. And so because I can't actually find the limit, look at my graph, I can't actually find the limit of 0 because it never actually touches where x is 0. So what is the actual answer here then? Negative infinity, yeah.
Everybody says 0, yeah, negative.
On the right-hand side, it's going down, right? Yep.
I love how that just works.
Wait.
Okay, so how about the next one? Limit as x goes to infinity of log of x plus 2, 20 minus log of x plus 2.
Log of infinity minus log of infinity.
Okay, so now you need to do some manipulating here. What do you think you would have to do for manipulating? Because if you plug infinity in here, log of infinity,
Minus log of infinity.
yeah, you can't actually do a calculation of infinity minus infinity. Yes, you can make this into a fraction. So let's go limit as x goes to infinity. And this would be log of, this is the same base, right? So this is x plus 20 divided by x plus 2.
Oh yeah, it's division.
Subtraction becomes division.
Right up here.
And remember, if we plug it in, infinity, the technique for limit going to infinity is we need to pull out the highest power, right?
Infinity over infinity. No, you cross.
Log of 1.
So this would be log, limit as x goes to infinity of log of, we're going to pull out the x, and we're left with 1 plus 20 over x, yes? And we're going to pull out this x, and we're left with 1 plus 2 over x, yes? The x's will now cancel. Do you remember this? So the x's cancel. And what happens when you plug infinity here? This goes to zeros. So what is this actually equal to? This would be log of 1. And so what is that equal to? 0. All right, let's move on. Okay, so now the next new derivative that you have to memorize is the derivative of a logarithm is 1 over x. And so if it's with the chain rule, it's 1 over u times u prime. So this could also be u prime over u, so it's like more simplified than. Okay, so how could we do y equals ln x to the power 3? Well, you could do this as a chain rule. However, I'll show you that either way would work. If you just pull a 3 in front, it's pretty easy, right? So if I pull a 3 in front, I get 3 ln x. So y prime would be 3 times 1 over x, which is 3 over x. However, say you didn't know that, and you treated this purely as a chain rule, then you would get, so if I use y equals ln of x to the power 3, y prime would be, remember, what this is 1 over that, so it's going to be x cubed on the bottom, and then this would be times the derivative of the inside, which would be 3x squared. And you see when you simplify that, you get 3 over x. So either way, you would have got 3 over x, but One way is way easier than the other. That's why I'm saying if you're not simplifying, you're probably not going to get the answers there, right? So that's why I'm saying I would memorize this form so you're putting it directly on top of each other. Okay, does everybody see the next one is a product rule? So go, do it. Do it. Okay. Y prime is 1 times ln. You don't have to put the 1, of course. I'm just showing my work. And then this is x. So this is 2x plus 3 times 2. So then I would probably slip that up there just to clean it up. So this is ln of 2x plus 3 plus 2x over 2x plus 3. This one's a chain rule and a chain rule. This is craziness now, hey? It is fun. Did you get a chance to do it? Did you get a chance to do this? You tried? Okay, I'll wait. Okay, derivative of ln. So y prime is 1 over that, right? Same thing. And then I don't do 1 over. I'm going to put the u prime there. So then the derivative of sine 2x is cos 2x times 2, yes? And then the derivative, then I did it, right? Yeah. So this could be simplified to, what is cos over sine? 2 cotangent of 2x. So be very wary. If it is a multiple choice, that might be the choice there, right? So, anyways. Weird. Okay, so sorry, if the logarithm has a base other than e. Okay, so please fix this. If the logarithm has a base other than e, not 3, I don't know why that's there. We simply insert the correction factor, just like we did for the extra ln e or ln a. This time the correction factor would be this extra 1 over ln of whatever the base is. So, anyways, moving on. So, what would the derivative be? So, do you see we have a chain rule? So, y prime. So, again, it would be, this goes to the bottom, yes? And then the derivative of this, so that would be 2x plus 1. And then the correction factor, because the e, it's on an e base, is times 1 over ln 3. So there's just an additional, I guess, step, is what I'm trying to say here.
And that was there before just the base with e. So.
Well, because ln of e would be 1, and 1 over 1 would be 1.
Yes. It's the same thing as before. 1 over, yeah. Mm-hmm. Okay, do you guys want to try the next one? Log of tan of x. It should be...
Oh, wait, where are you?
This right here is an e. Is a 3.
That's the base.
It's the base of the logarithm. So if it doesn't have a base listed, like for it, it's 10, yeah. No, it's a superscript, right? Sorry, it's a subscript. It's a subscript, right? Okay, so y prime would be, put the tan x on the bottom, right? And then, oh, look at you. Secant squared x on top, and then what do we have to do the correction with? 1 over ln 10. Very good. It's easy. You just have to memorize that thing, the technique. Oh my gosh, now we have this. Can you handle it? Can you do it? Can you handle it? Okay, so the derivative of cos would be minus sine of the blob, which is... Then you got to times it by the derivative of this inside function, which the derivative to the power something is same thing. So 2 to the power the same thing, but you have to have the correction factor in there, which is ln of 2, and then you have to find the derivative of that, right? So what's that? yeah, secant 2x tan 2x times 2. So I'm going to put the 2 in front there. Watch when you say secant tan. It's secant of the 2x, tan of the 2x, right? And then the derivative of the 2x is the 2. Okay, logarithmic differentiation. The other rules do not work if there is a variable in the base. Do you understand that? All these rules that we memorized, it had a number as the base, right? So if I have a variable as the base, we use logarithmic differentiation. Okay, so the steps in taking logarithmic differentiation is take the natural logarithm of both sides of an equation and use the theorems of logs, or the rules of logs, whatever you want to call it, the theorems of logarithms to expand.
So you're trying to get that variable because it's the exponent.
Yes, yes. So then we're going to differentiate y with respect to x, solve the resulting equation for y prime. So here is the one example I'm doing. Oh, actually 2 examples. Yeah. So does everybody see y equals x to the power x? You cannot use any of the memorized things because we don't have, like the base is not, the problem is this base here, right? It wasn't the x there, it's this x that's the base. So if I ln both sides, what do I get? ln of y equals ln of x to the power x. Does everybody see I can now write this x in front? Yes? So I get ln y equals x ln x. So now I'm going to differentiate. I'm essentially going to do implicit differentiation, right?
Yeah.
I'm going to do implicit differentiation because I can't solve for my y at this point to do y prime. So what is the derivative of ln y? It's 1 over y and then y prime. So it's going to be y prime over y equals. Now, does everybody see on the right-hand side, this is now a product. So I'm going to just circle the products. So I'll give you a sec. Okay, so 1, yeah. 1 ln x, if you want, I'll put brackets, plus x. If you want, 1 over x, yeah. Yeah? Which is x over x, which is 1, yeah. So I'm gonna do, I'm running out of room here. Maybe I'll go, okay, so I'm gonna get y prime over y equals ln x plus 1. Is everybody good with that? Okay, so we need to solve for y prime, so we need to get rid of the y. And so cross multiply it over, I get y prime equals y times ln x plus 1. However, I can't leave it as this y here. So what does y equal again? Right there. So y prime equals x to the power x ln x plus 1. So this would be my final answer. Well, no, I think it wouldn't be a matter of memorizing x power. They would hardly ever ask the exact same question again. But I guess if you had this in your memory bank and it was a multiple choice, you would recognize it. But do you see the next one is, hold on there. Okay, let's just wait a second here. Okay, so I'm going to ln both sides. So ln y equals sine x ln of cos x. Everybody good with that? And then this is a product rule here. So y prime over y equals, the derivative of sine is cos x ln of cos x plus sine x, the derivative of ln would be cos x on the bottom, and then a minus sine x on top. Yes? So then y prime over y equals cos x ln cos x minus sine squared x over cos x times what together? Well, I'm gonna cross multiply that over. So y prime is going to be cos x to the power sine x bracket cos x ln cos x minus sine squared x over cos x. I'm sorry, can you make what?
You can because it's not, it's all that it looks like.